All right, so we're going to look at second derivatives, third derivatives, and so on. So we've been talking about f being a function. We just looked at the last problem. Where was it? Right here. Where 24, we started with function, and the derivative was also a function. F prime is also a function. So if the derivative is a function, then you have, sorry, this thing's going to get in my way here, then its derivatives may also have a derivative. Okay? So you got the derivative of the derivative, which is the second derivative. This is what it looks like. Typically, that's the second derivative, which is the derivative of the first derivative. And we can keep going. We typically don't have a lot of applications to keep going, but we'll do it. Okay? This is also a symbol for a second derivative. Okay? Now I can tell you on the test, people come up to me and say, and they'll say f of x equals whatever, and find this. And I'll have people up at my desk like, I don't know what that means. Okay, well, that's part of the deal, is that you understand the language, the notation, all that. If I wrote this, hopefully you would have known that. So these, you'll see both of these. I didn't make up the symbols, so don't blame me if that doesn't algebraically make sense. Okay? But you're going to see it like that. The second derivative is right there. That's what it looks like. Okay, so f double prime will be the slope of the f prime. Okay, so say you had f of x looks like this. Okay, what do you think f prime of x is going to look like? A line. Good job, Francis. It's going to be, okay, so it's going to be something like this. Okay, if you don't know that yet, you will get there. Okay, I was going to pull that up here. Okay, and all right, now that line, let's say it's, we're just going to make up stuff here, 2x plus 6. What's the slope of that line? 2. So what's the derivative of that function? 2. So f double prime would look like 2, and that looks like this. Okay? All right. So let's go and do one. Okay, so f double prime will be the slope of f prime. It is the rate of change of a rate of change. And have you all taken physics? Or are some of y'all taking it now? Yes, you're not taking it? You're taking it now. Okay. Acceleration is the derivative, the most common second derivative. So it's the second derivative of the position function. So if you want to find the acceleration, you're going to use the second derivative. All right, so let's start an example here. It's going to take us a little bit here. I'm just going to erase that. Okay. All right, let's find f prime of x. I feel like we did this in this lesson already. Did we? Does that look familiar to you? This guy, x plus h, I feel like we did it. Okay, good. Blah, blah, blah. Yada, yada, yada. And da, da, da. We should get 2x minus 1. Okay? All right. We did it already. Okay, so now let's take and find f double prime. Okay, so this is f prime. So how do you find the derivative of 2x minus 1? You start over. You say take LM limit as h approaches 0 of, this is now your new f of x. Okay? So what does the new f of x plus h look like if our new f of x looks like 2x minus 1? Okay, very good. Minus, oops, sorry. Minus 1 minus f of x. X is 2x minus 1 all over h. Okay? We're just finding a derivative again. The function is, what we're looking at now is 2x minus 1. Okay? So technically, if you want to do, this is the prime, but don't worry about that. You're still using the same thing. All right, so limit h approaches 0. We already said 2x plus 2h. What's the rest of that look like? Minus 2x? Plus 1. Okay. All right, so we got our minus 1 and plus 1 is going to go away. 2x and negative 2x is going to go away. H is now going to go away on the bottom, which is fabulous news. So our derivative is 2. Okay, so first function was x squared minus x. F prime was 2x minus 1. F equals 2. Okay? So, thank you. Thank you. Okay. All right, let's take a look at the graph, although throw them in your calculator. Just because that's what we're going to want to do is pick them out. Now, if this was, while you're waiting, this was the position function. This would be the velocity, and I know we haven't spent a lot of time on that yet, but we will. This would be then acceleration. Okay? All right. All right, so we got x squared minus x, we got 2x minus 1, and now we have 2. All right. Okay. So let's talk about these three graphs, shall we? Okay. The black is f of x. Okay. So where what's happening from here to about right this point? What is happening with that? What is it? Decreasing. Awesome. So f of x is decreasing there. What is happening at the same time with the purple, pink, whatever you call that? No. It's all increasing. It's all increasing, right? So that's not the right language that we're looking for, but it certainly is increasing, is negative. F prime is negative. And hopefully you've made that connection when you were drawing those graphs that you enjoyed so much. Okay? And it's negative to that black dot that I created there. Okay? Now look at the black on the other side of the black dots. What is happening here with F? F is increasing, and what is happening from the black dot on to F prime? It's positive. Okay? All right, now let's talk about the purple being F prime. What is F prime doing the whole way? Increasing. What is F double prime doing the whole way? It should be positive, that's right. Remember, positive is where? On the graph. Above the x-axis, negative is below the x-axis. Okay? So, We're going to back up one slide, and we're going to pick out F, F prime, and F double prime. Okay? Now, some of you already, Francis has picked up this last class about, you know that if it's a polynomial, then the degree, let's look real quick, the degrees here are decreasing. So the degree of this guy is 2. The degree of this guy is 1. The degree of this guy is 0. Okay? So, oh, by the way, we were going to do the third derivative. Okay, we usually will see it like this because it just kind of smooshes all. That's what the third derivative looks like. Rarely can you even see it, but you may see it down the road, I don't know. Okay, we usually don't do this, we do that instead. What do you think the third derivative is? What's the derivative? What's the slope of that 2 lines? That's right. Okay, remember the green line? It has slope of 0. And the fourth derivative, all these now will be 0, because they're all 0, 0. Anyway, so at some point they all turn into 0. The polynomials, that is. Okay, so use that if you think your function is a polynomial. So we're going to back up, and we're going to do this one together. Okay, those look like polynomials, no? All of them on figure 1? Not all of them? Okay, what kind of polynomial does this look like? We had to put a name on its degree. A cubic. So what degree is that? Okay, what about this guy right here? 2, degree 2, degree 3, degree 1. Okay, so I bet you can tell me pretty quickly which one is F, which one is F prime, and which one is F double prime. Which one do you think is F, Lauren? The dashed, the gray, or the bold? The dashed one. We're going to check them out. We're going to check the whole increasing, decreasing, positive, negative business. Okay, good job, Lauren. Megan, which one do you think is F prime? The parabola. And that leaves, oops, sorry. You said F prime and I wrote F double prime. Okay. F prime is the parabola, F double prime. Okay, so now let's check it out. Starting with F. Okay, what's happening with F? It's increasing all the way. Okay, F is increasing. F prime should be what? Okay, is it? Yes, this is all above the x-axis. Okay, cool. So that checks. All right, now remember that doesn't mean that we have line or done. It means that that quadratic or this parabola is the derivative here. If we started wrong place, that might not work. All right, so what about F prime now? As far as increasing and decreasing, this is the quadratic. Where does it start decreasing until we get to about right here? Okay, and so decreasing to the dot. And what about F prime at that same place? It's negative. Okay, and then it's positive from the dot to the rest of, and remember we're talking about an x value, so this has some kind of x, let's say 1, okay, x equals 1, and then from negative infinity to 1, okay. All right, so now, just forewarned, you're going to do this one, you're going to give it a shot. These no longer are polynomials, so you got to use the whole decreasing, increasing. My suggestion is just like say, okay, close your eyes. Not really, but let's say this one is F. I'm just randomly appointing it and then saying, okay, what is it doing? Which one is positive, negative in that respect? So work on it a minute.
When we said F1 decreasing to x equals 1, we said F1 to negative, didn't we have to
Yes, thank you, Mara. Jeez. Keep me.
Is that another step?
Yes, that is a check. Yes. That means that fits. We're trying to figure out if we had the right names appointed for the right graphs. And you have to check them out. You're just like, yeah, let's say this is this. Well, then this one has to be this one. No, that doesn't work, so back up. Yes, Ella. Cora, sorry.
Why, like, how did you name the function? Did you just, like, how did you know there's F prime?
I didn't know. I was guessing, and we were basing that guess on what? Right. Knowing what we know about derivatives, we were guessing that this was a cubic, and then this was a quadratic, so this guy would be the derivative of this guy, knowing that your degree is less. And then we're just checking out, okay, as this increases everywhere, this is positive, so this parabola is definitely the derivative of this guy. Because of the whole increasing, decreasing, positive, negative business. Where F is increasing, which is in this case is the whole thing, then F prime is the whole thing being positive in that same interval. And then on here, if we look at this point right here, and we said that was just one, just for conversation. F prime, this function now is decreasing on the interval from the end of this graph, negative infinity, to 1. This function right here is negative because it's all underneath the x-axis on that same interval. So that means that is the derivative of that guy. Okay? So you're going to do the same thing with that figure 2. I'm going to put this back on. Let's start wrong. These are right, but let's pretend we started. Where did we start? Remember before? Did we start here?
No, the last one.
Okay, so let's just pretend we don't know. And let's make this F. Okay, what do we know about F? It's increasing. So, yes, but we can't start with negative and positive. We have to start with increasing and decreasing. So if F is all increasing, F prime is all positive, which would be this one, right? Okay, what about this one, about increasing and decreasing? This one's decreasing, right? Then F double prime, this is the only one we have left. That's not all negative, is it? Okay, so we're wrong. Okay, so we start differently. Okay, and we already talked about that. Does anybody need to hear it again? Let me get rid of all the X's because those are the right answers. What the heck? Where is I? Let me just start over. Okay, I'm happy to say that again if you need it. Anybody? Not really. Because you don't really have a lot of information. So you just, and you'll get better at guessing, and then, and sometimes you grab this one F, and this one definitely is the derivative of it. You just didn't start the right place. So you just know that works for its derivative, but let's try that other one then and see if we can start there. Okay? So when you do this one for F, this one would be F prime, but we got a third one that we got to make work in there too. Okay? All right, so I think we're ready for 2-8 now. Yeah.
The first one.
This one is, okay.
The parabola is increasing and decreasing. Is that why second prime is both
Negative and positive, yes. And this is, I think, those are exponential graphs. So that's why you can't use the whole degree thing. The degree thing is nice if you recognize it, but otherwise. Okay, we're done with 2-7. Let's move on. You guys should have 2-8. It's in pink there. Right there. Okay. There's a lot of graphing, but it's a lot of just like, it's graphed. Let's look at it. You don't have to put it in your calculator if you want. My window is right here. It's just mark your graph 0 to 2 pi. Okay, this is pi. This is pi over 2. That would make that 3 pi over 2. That is the beautiful sine curve. As you know and love it from last year, right? All right, so we are going to start working in that unit circle. So hopefully that is not rusted totally away. All right, so we don't really care that it's the sine function. That's just like a bonus. We're just going to look for increasing and decreasing again. Okay, we're introducing some new vocabulary, some just reiterating what we just talked about. Okay, so where is this function increasing Cora? And we're just looking from 0 to 2 pi. Okay. Okay. All right, very good. Any discussion on that? Increasing here to here and here to here. All right. Where's F decreasing then, Sarah Smith? Yes. All right, did you lose your voice? I was going to guess that's where it went. All right. Okay, so what is F prime supposed to be if F is increasing? Positive. Okay. What is F prime supposed to be if F is decreasing? All right, so you don't know this yet, but you have a derivative function key on your calculator. So this right here is the derivative F prime. Okay, you recognize it? It is cosine, Francis. Good job. Okay, again, we're just looking from 0 to 2 pi. That's pi over 2, and that's 3 pi over 2 still. Okay, now we're talking about F prime. Okay, where is F prime increasing, Tessie? F prime, which is this graph right here. Increasing? Where's it increasing? We're not doing negative pi, we're only going from 0 to 2 pi. So we're starting here and going to here. Which part is increasing? Okay. 2 pi. All right. Erase this. You're good. You're good. Okay. All right. And where is F prime decreasing, Maddie? 0 to pi. Okay. Now remember, the relationship between F prime and F double prime is the same as the relationship between F and F prime. So on this interval, F prime should be what? F double prime should be positive and negative down here. Decreasing, its derivative is negative. Increasing, its derivative is positive. Okay. Let's take a look before we look at F double prime. I got to put this down to double screen so I can actually look at the whole page here. All right, let's take a look here. On F prime was 0 to half pi. 0 to half pi is positive. Is that true right here? Yep. And again at 3/2 to 2 pi. So that does verify that. The graph verifies what we thought according to the theory. Okay. So let's see. Negative is this guy underneath the x-axis right here, which we said it was pi over 2 to 3 pi over 2. So the graph does verify. All right, one more thing. Let's look at the, oops. F double prime. You won't recognize that one, but this is F double prime now. If you thought about it, you could, but this is the graph of F double prime. Okay. Where is F double prime positive? I said it's in there twice. Oh, it's different ones. Okay. This is F double prime. Where's F double prime positive? Laura. And again, we're just looking at this. Very good. Okay. All right. There's the same thing here. I'm losing it. This is F prime, though. Okay. And what interval, on that interval, what is F of X? Let's look at pi to 2 pi. All the way up to F of X. Pi to 2 pi. Pi to 2 pi. It's negative, but a better name would be concave up. Okay, do you all remember concavity from the parabola from your polynomial last year? We've been early on. Concave up is a parabola opening up. Concave down is a parabola opening down. Okay, so if not, it's just new vocab. It's all right. Okay, where is F double prime negative? Wait, this is F double prime. So where is it negative? 0 to pi. And that, if you look at 0 to pi, it is concave. What's that? If it faces down, that's concave down. Okay? Concave down. Okay. All right. Let's look at where is F double prime positive? We already said that. Okay, I think these are different. On that interval, what is F prime of X? Look at F prime of X. F prime of X on pi to 2 pi. What did we call it before? Pi to 2 pi. What do we call that? Increasing, that's right. Increasing. Okay. And F prime is negative. Again, at 0 to pi, I'm not losing it. This is what I wanted. Okay. And what is F prime on 0 to pi? Let's look at F prime. F prime 0 to pi. What is that? Decreasing. Okay. So there's a lot of words floating around here. Let's make sure we're talking about the right words. So give yourself a little space. F is increasing. F prime is positive. Okay? F prime is increasing. F double prime is positive. F is concave up. Okay? So that's why we no longer can say it's doing that. What are you talking about? Are you talking about F? You're talking about F prime? Okay? F is decreasing. What do we know? F prime is negative. What about F prime being decreasing? Decreasing and negative are not the same thing. You do know that, right? It could be, but they're not necessarily the same thing. Decreasing F double prime is what? Decreasing. Its derivative is negative, and that is, sorry, I should have wrote this out. Concave up. This is concave down. Okay. The same relationship between F double prime and F prime, except we don't talk about it we talk about concavity. In F to F prime, we talk about increasing and decreasing. Okay? So those are all the words. And let me just say, you're going to get mixed up. So you just got to keep reinforcing them. Oh, sorry. No.
Is that only that it's like find that?
No, that's anytime. Good question though. I used the F, and maybe that's not a great example, but it has, you know, I just wanted to get the trig back in here. Part of it. Okay? All right. You good? Got it? All right. Let's talk about sine of x on 2 pi. What's the local max? So you have to look at the picture, go for it. What's the local max? It'll be right here. Okay. All right. Where is that found theoretically? That's not theoretically, that's specifically. What's on this side opposed to what's on this side? Sorry. You see where it is? From 0 to half pi is what? What do we know about f? It's increasing and it's decreasing on the other side. Okay, so the local max is at x equals pi over 2. Theoretically, it will occur when f changes from increasing to decreasing. Okay? What's f prime doing there? What's f prime doing there? Is it f prime is positive here, and it definitely is negative here. Yes, f prime is changing from positive to negative. So you're going to have all these reasons, but they're all related to why it's a local max. And no longer are the days where we're going to look at the graph and say, oh yeah, it's the local max because it's the highest one up there. Okay, we'll have to give one of these 2 reasons here. Okay, what's the local min down here? Where was that at? 3 pi over 2? Isn't that where the local min was?
Yeah.
Yeah. Where is that? What's on this side? Decreasing to increase. Okay, so this occurs when f changes from increasing to decreasing. Sorry, I'm copying and I'm not paying attention. Decreasing to increasing, or when f prime changes from negative to positive. Okay? You don't have to go to inflection point today. So I'm going to skip this and go on to the next page. Are you ready? Just for now, we already talked about that. Let's look at an example, because this is what you're going to have to do for homework. And these problems right here. Okay. Is everybody ready? Okay. All right. So here is the example of what we're going to do with that information. Okay. The first thing you have to understand is this is not f, this is f prime. This is the derivative. Okay? Now, we don't want to have to draw f, because that would be a lot of just trouble right now. We just want to know, where is F decreasing? Okay, now we're not looking at F. We're looking at F prime. So theoretically, what's happening to F prime when F is decreasing? Good. It should be negative, right? F decreasing, F prime is negative. Okay, now we can look at the graph. On the graph, where is this F prime negative? Where is it negative? Where? It is indeed. Okay, this is negative. Right here, underneath the axis. Okay, good job. Okay, where's F increasing? Remember, that's where F prime is positive. When your graph, you're above the x-axis here and here. So, negative infinity to negative 1, and then again 1 to infinity. Okay? All right, knowing that, do we have a local max? Let me write positive, negative, negative, positive, where it crosses over. Okay, go back a page. Remember, a max occurs, we're looking at F prime, so you want to make when it changes from positive to negative. Okay, so where is it changing from positive to negative? It's positive, it's positive, it's negative. So there must be a max at x equals negative 1. Does that make sense? Okay, is there a local min? Yes. Where's that? Yeah. Because that's where it changes. Remember, when we're changing, we're reading this map. This is a graph. We go from left to right always. Plus to minus. That's the max. Negative, 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 negative. Oh, we cross over plus. Right there is the positive one. So that's your local max. And what do we know about this guy here? What is F prime? I think that's the third question down there. I can't really see. Come on. F prime of x. All the way down here. F prime of x equals 0 at 1 and x equals negative 1. And those are their local max and mins. Okay? So for now, you're looking at a graph. And be careful, you're going to be crazy for a little bit because you're like, wait, you'll be thinking you're looking at F and you're looking at F prime or vice versa. So be careful. That's why I said, while you're doing these, make sure you check your odd answers. Just make sure you're on the right track and not like, oh my gosh, I thought I was looking at F. They're very clear, but you got to put your mind in it there. Well, yes, there's understanding, and then there's not getting confused when you put it together. Yes, that's good. Friday I got a meeting, so really. And it's 157, yes. That's that same exercise that we did. We're pulling the end of those up. And we got, oh my. Well, yesterday I went to the guy called. That's always fun, right? Y'all done that yet? Okay, good parents are letting you do that before you graduate, like not my daughter. Oops, I forgot about that little detail. So before you even got home, they're calling me. And I'm like, this can't be good, right? Your pap smear was normal. I was like, okay, thank you. It's like, in an hour, they were calling me. You know, they have to send that to the lab, and y'all have not been to the gynecologist. Okay. It's a joyous experience, let me just say that. You're supposed to do that before you go to well, yeah. The pediatrician is supposed to say, see ya at 18. Because there are things that he doesn't want to deal with.
Dustin's person or she is a pediatrician.
So, anyway, that was more information that you wanted from me. I'm so sorry. Oh, gosh,